Hello, my friends. Welcome to my YouTube channel. I'm sure you're liking my videos. Please give your comments so that I can improve my videos. It is all which I'm doing, that spreading knowledge. If you find there's some issues, if you find the presentation is not good, or if you find the presentation good, please, whatever, please give your comments. Thank you so much for watching. Let us look at one of the important aspects of today's world, data. And when you come to data centers, huge business. Now you go to any part of India, Mumbai, Hyderabad, Bangalore, data centers are coming up like mad. You go another part of globe, you'll find data center is hot cake. How the data center works? They work because most important aspect is HVAC. How did we use internet or used to call or we used to have online call during COVID? Because data centers were running. And why they were running? Because HVAC was running. So take credit. That we were also responsible for running your internet, for having your Zoom online meetings, right? Or any kind of online meetings, or even mobile phone working. Data centers are in demand. What are the 10 steps for HVAC design for efficient data center operation is what we are going to look at in this video. There could be more steps, right? Let us look at 10 steps. One of the important aspects in this data center is heat load calculation. In data center, the major source is sensible, the heating, right? The latent heat is less, but if it is there, we need to calculate, and we should be very clear about total heat load. Sensible plus latent. Sensible plays a very, very important role in data center. Based on this, we should also decide the number of air changes. The number of air changes depend upon obviously the volume, the contaminant, the filtration level, the oxygen supply, the thermal comfort, a lot of other aspects. But we must be very clear about the airflow rate, the ventilation requirement of data center. The third aspect is cooling system sizing. You need to be very clear about the chiller capacity. The major issue when you select the chiller is if there is a power outrage, the chiller has to come work on DG. There should not be major gap, right? So the quick restart is important. The maintenance of the chilled water temperature, because we're talking about higher chilled water temperature here, is important. So you need to be able to size the chillers. If the requirement is huge, how do you have a modular chillers? What size of those chillers? Based on the size, availability of space, and based on your requirement. Very, very fine balance needs to be maintained. Similarly, for the low side, the precision ACs, right, or crack units which you call, they have to be designed properly. If we don't, then we will have problems later. The fourth step is air distribution. You need to be very clear about, most of the time these are raised floors, but even if they are not, we need to have proper air distribution so that the hot aisle and the cold aisle, the configuration has to be understood properly. Implement the air distribution based on these hot and cold aisle. Hot and cold aisle have a proper distribution. The distribution of the quantity, air quantity where it is required has to be required there, not somewhere else, right? The concept is a little different here. Humidity control. The data center are sensitive towards the moisture, and that's why we need to have proper humidity controls, heaters or dehumidifiers, or whatever the way, what humidity control they need, we need to be able to maintain that. We cannot just really put it on the coil, and there's a lot of variation because the seasons are also changing outside. Energy efficiency. Data centers are energy guzzlers. How can we have energy efficient HVAC systems? Try to have variable steam drives, try to use a lot of free cooling, try to have the heat recovery systems. What are the best possible measures we must think, because this is huge energy guzzler, and the HVAC requirement is also huge. So you need to find the right balance, the optimum energy efficiency through various interventions: free cooling, heat recovery, variable drives, uh, the chiller efficiency, and the entire system efficiency. It's not that you put chiller which is highly efficient and the other system is not going to work. System has to be very efficient. We should have proper BMS control to see that yes, it is running that efficiently. Otherwise, just on the paper and it doesn't run outside is a big issue. Step number 7 is redundancy. As I said, we can't have outrages, we can't have breakdowns. There has to be n+1 redundancy, and that's the system which is to be placed, because we can't have any stoppage. 8, CFD analysis. To get right airflow, you must use CFD analysis so that you can get right airflow patterns. Use this, it will help. 9, monitoring control. I just talked about having designed a system, having implemented a system, and not operating the way it is supposed to be. It's not going to help. There should be BMS, building automation system, which should be working properly, giving the right data, and ensuring the alerts so that you can take corrective actions and make sure system runs smoothly, system runs efficiently. There are some alerts are given in advance. Last is filtration, depending on the requirement. If the HEPA required, yes, we need to go for HEPA, but again, your fan sizing, the motor capacity will go up. Filtration plays an important role because we can't have servers or racks getting dust from the outside fresh air or the air which is getting routed through our crack vents. So these are some of the important steps I thought for designing of data center, which will be helpful for you. Gentlemen who are just coming into this business, data center business, these steps might help you. Please subscribe my channel, follow me on YouTube, Facebook, LinkedIn, ajazkazi.com. Thank you so much.